Out at the very edges of our solar system, past the orbit of Neptune, billions of comets drift through a pitch-black abyss. It is unimaginably cold out here, often hovering just a few degrees above absolute zero. Because of that extreme chill, we thought of these objects for a long time as simple, dirty snowballs. They were assumed to be ancient, frozen clumps of primordial ice and dust left over from the formation of the solar system. But when we actually analyzed the material inside these icy bodies, we found something contradictory: crystalline silicates. This diagram shows the problem. On one side, the ice that makes up a comet requires incredibly low temperatures to survive. But on the other side, forming a silicate crystal requires blazing, intense heat. You have to bake ambient dust at hundreds or even thousands of degrees until it essentially turns to glass. Those two environments simply do not mix. Astronomers had no logical mechanism to explain how minerals forged in a cosmic furnace ended up trapped deep inside ice from the coldest, most desolate reaches of space. To figure out how this happened in our own solar system, we had to look far beyond it, 1,300 light-years away, to catch a baby star in the act of creation. We were able to get that distant view thanks to the James Webb Space Telescope. Its mid-infrared instruments are sensitive enough to pierce through thick, obscuring clouds of space dust to observe stellar nurseries. Webb recently focused those mirrors on a protostar cataloged as EC53. It's a young, actively forming star, heavily wrapped inside a swirling disk of gas and dust. Right next to the star itself, the innermost ring of that disk is an absolute inferno. Webb's data showed that this ultra-hot inner region is functioning as a cosmic forge. The heat from the central star is literally baking the nearby ambient dust into the exact same glass-like crystalline silicates we find in our comets. But locating the forge introduces a massive logistical problem. Those newly manufactured crystals are now trapped inside the star's hottest zone, millions of miles away from the freezing outer edges where comets are born. Finding the source of the crystals is a major discovery, but for them to reach the comets, they must survive a journey through the vast, freezing expanse of the protoplanetary disk. Luckily, EC53 operates on a highly predictable schedule. Most of the time, the star quietly nibbles away at the dust in its disk, but about every 18 months, it transitions into a violent burst phase. For 100 days, the star completely devours the material around it. It takes in so much matter so quickly that it violently ejects the excess as powerful jets and massive outflows of luminous gas. By taking highly detailed spectra during both the quiet and active phases, Webb's instruments mapped the exact trajectories of these violent expulsions. The star's powerful outward winds act as a cosmic highway, scooping up freshly forged crystals from the inner ring. They are catapulted out of the heat zone, flying across the protoplanetary disk until they deposit into the freezing outskirts. This cyclical 100-day eruption explains how fire and ice eventually meet. We now have concrete observational proof of the mechanism that transports heat-forged minerals to the coldest zones of a forming star system. Once those newly arrived crystals settle at the extreme edges of the EC53 system, the cold takes over. Over millions of years, in the freezing dark, ice will slowly accumulate around these crystalline grains. Endless collisions will clump them together into larger and larger icy rocks, eventually building the comets of that new system. The violent, chaotic factory phase we see right now won't last. Eventually, the excess dust will clear, planets will finish taking shape, and a calm star will remain at the center. By observing EC53, Webb is capturing the same physical processes that likely shaped our own solar system billions of years ago. The specific silicate crystals Webb detected in that distant forge, minerals like forsterite and enstatite, are the exact same common minerals that make up the vast majority of the Earth's crust. The solid ground beneath our feet and those icy comets drifting through our sky share a single origin, forged in a violent cosmic factory during the chaotic birth of our solar system.